Okay, so let's look at the Chapter 5B review problems, or it's probably just Chapter 5 review on the handout. Um, and number one. And these problems are about factoring polynomials as much as possible. And so my guess is, I haven't actually looked at these yet, but my guess is they're going to use a couple of rules that you had to learn. Um, at some point in Chapter 5, you learned that if you had the sum of two squares, that actually, or sorry, two cubes, that factors into a plus b times a squared minus ab plus b squared. Now, if you wanted, you could memorize a minus version as well, but if you really have something like let's say you had 4 cubed minus x cubed, you could just think of it as 4 cubed plus negative x cubed, and then just use this formula up here, where your a is 4 and your b is negative x, and that'll work fine. So really, the only formula I actually memorize instead of an a plus b cubed, or a cubed plus b cubed, and an a cubed minus b cubed, I just memorize the one. That's all you really need. If you want to, you can memorize the other one. Doesn't matter to me. But I'll show you how I solve part A with that. Then the other common one that comes up is a squared minus b squared. And usually you need to remember that that's going to turn into a plus b, a minus b. If you don't remember that, you can do this sort of thing. It's got to multiply to ab, and it's got to, what else? Or if it comes up, we'll do it. All right. So, so these are the two formulas that come in handy for factoring. So in the first one, we've got a 125x cubed minus 8. So let me just write that here. 125x cubed minus 8. Well, you might be able to recognize 125x cubed is really 5x all cubed, and 8 is really 2 cubed. So I'm going to rewrite it so that it looks like a cubed plus b cubed. So that's 5x all cubed plus negative 2 all cubed. So now it's in the form a cubed plus b cubed, where the a is 5x and the b is negative 2. So then really if I just plug it into this side, then I've got the factored form. So on that side, it's a plus b, so that's going to be 5x plus negative 2. And then I've got a squared, which is 5x squared, and then minus ab, so minus 5x times negative 2, and then plus b squared, so plus negative 2 all squared. And so then if I simplify, well, the first parentheses just turns into 5x minus 2. And the second parentheses turns into, so 5x times 5x will be 25x squared. And then 5x times negative 2 is negative 10x, with another negative makes it plus 10x. And then negative 2 squared is going to be plus 4. And then that's it. That's as far as you can go with this. So there it is in factored form. That's A. For B, let's take a look at B. So B is 2x to the fifth minus 12x cubed plus 10x. And we need to factor that. So the first thing that you can hopefully see is can you take something out of all three terms? And you can take a 2x out of everything. So if I take 2x out of the first term, I'm just left with 1x to the fourth, and then 6x squared here, and then a plus 5. Now you might be able to figure out how to factor that without needing to do this, but it's actually what I call a disguised quadratic. X to the fourth, x squared, and then just units. Well, if you think of y as x squared, let y equal x squared, then I can rewrite, we'll just leave the 2x alone because there's not much we're going to do with that. But then you can write this, x to the fourth would really be y squared. So it's y squared minus 6y plus 5. And then that's a quadratic. So really the one before it is a quadratic. And And so to factor this guy, well, actually, I'll do this on the side here. So let's just look over here. Let me extend this. Okay, so over on the side, I'm going to factor y squared minus 6y plus 5. Now, if you're good at just going straight to this form, no problem. Just do that then. But if not, you can do this. I don't remember what that thing's called, the x method. We know it has to multiply to 1 times 5, which is 5, and it has to add to negative 6. So the two numbers that do that would be negative 5 and negative 1. So this is going to turn into y squared, and then these two numbers split that middle term. So it's y squared minus 5y, and then minus 1y plus 5. And then that'll turn into, if we take these first two terms, I can take out a y, so y minus 5. And then in the second two terms, I'd have to take out a negative 1 to get y minus 5 as well. And then I've got y minus 1, y minus 5. So that's what that parentheses turns into. So now I've got 2x, y minus 1, y minus 5. But y is something I made up. Y is really x squared. So this is really 2x, x squared minus 1, x squared minus 5. Now, you might think you can stop there, but it turns out you can actually break down this one a little bit more. Whoop. That one's going to turn into 2x. It's really the difference of two squares, where a is x and b is 1, because 1 squared is 1. So then it turns into x plus 1, x minus 1. So this thing turns into x plus 1, x minus 1. And then the x squared minus 5, you could think of b as root 5, because b squared would then be 5. So this would turn into x plus root 5, x minus root 5. I don't actually care if you deal with the roots or not. If it was a 4, then I'd want it to be x plus 2, x minus 2. But if it's a 5, then you end up with roots. So a lot of times you just leave it, and my guess is that your textbook also leaves these as x squared minus 5. Okay. So I know that's what the answer key says is x squared minus 5 somewhere. So this is good enough. But again, if it's like a 4 or a 9 or a 16, then I'd want you to keep going because that's a nice number that you can factor out. Okay, hope that helps a little bit.